Hey everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science quickly and easily. Okay, so today we're going to be going through water and wastewater. Alright then, so some key points. A pure substance is a substance that only contains one type of atom or compound. So in regards to water, if you took it here, it would just have, if you had a pure water droplet, for example, it would only have water molecules in and nothing else. Tap water, water from rivers is not pure because it will contain other things in it like little calcium salts, carbonate ions, that kind of thing. And so it's not pure. Potable water is water that is safe to drink and it contains dissolved salts or dissolved solids. Now, water that we drink should have sufficiently low levels of salts and microbes so that it becomes potable. So basically, potable water is any water where the levels of salt and microbes are low enough so that obviously we don't have any harm from it and it does us our, the good that we need it. Okay, so you can distinguish between pure water and potable water by using its boiling point. So remember, a pure substance has a fixed boiling point. So for example, water would boil at exactly 100 degrees. Whereas impure water, so most water samples that we come across from taps and things like that, will have a range. So if we measure it very accurately, it will measure, say, 99.9 degrees to 100.2 degrees or something like that. It'll have a range, whereas pure water will go to exactly 100 degrees. Okay, so drinking water in the UK then. Doesn't necessarily have to be just the UK, it's other countries as well that have lots of fresh water, lots of rainwater, but we'll specifically focus on this country. So we would choose an appropriate source. So if you had a question where it would ask you how would you get water in the UK, you would first choose an appropriate source. So that could be a lake, a river, or a stream, or an aquifer you might have heard of. You basically choose a suitable source that's got some reasonably clean water in. Okay, but obviously if you went down with a pint down to the local river, grabbed a pint of water from the local river, you probably wouldn't drink it straight away. What are you going to do to it first? You're going to filter it, and that is to remove the solid. And we often do that through filter beds in this country. And then we're going to sterilize it, and that kills the bacteria. Now, in this country, we mainly use chlorine to do that, but you can also use ozone or UV light are perfectly acceptable in your answers as well. So, essentially, it's relatively straightforward for river waters, groundwater, stuff like that. Choose an appropriate source. We filter, remove the solid, sterilize, kill bacteria. Job done. Okay, so some other countries then might be a lot hotter, kind of arid countries. They might not have plentiful supply of fresh water, groundwater, lakes, rivers and streams. So what they're going to use instead, they're going to use maybe the sea, so it's going to be salty water, or it might be a lake that's particularly salty. So you need to desalinate. So that is, we remove the salt. So that's obviously if the fresh water is not available. So we remove that salt from the water. That's called desalination. And there are two ways you can do that, which we also need to learn. First one is we distill it. And that's essentially we just evaporate and we condense the water. The other way we can use is reverse osmosis. Now there's a slight advantage, to distilling. And if we distill the water, we also sterilize it because we're boiling it. Whereas reverse osmosis, we often would have to use chlorine, ozone or UV light to sterilize it again afterwards. Both of these methods are very expensive and they require lots of energy to do that. So they're not ideal. We would rather just find a suitable source, filter it and sterilize it. But obviously if you can't do that, you have to do these more expensive methods. Wastewater. Okay, so there are three types of wastewater. We've got household and agricultural. So this mainly contains organic matter and harmful microbes. And then you've got industrial, and this contains organic matter and harmful chemicals. So how do we treat this wastewater? So all of this wastewater ends up going into the sewers and it goes into your sewage treatment works. Now, when we say organic matter, we're obviously talking about when you go to the toilet, so your pee and your poo that goes down the toilet, but also things like skin cells, hair when you're having showers, but even organic matter, things like leftover food that people rinse down the sinks or the dishwashers, and then chemicals we could be talking about maybe a bit of fairy liquid, kind of detergents that go down there. Industry might pour paint and things down there. And then obviously agricultural, there could be things like fertilizers and there could be other kind of animal waste that goes into the sewers as well. And all of this sewage needs to be cleared up. So the treatment for wastewater, very important to learn. You've got step one is screening. and that removes kind of your grit and your large solids. So this is slightly different to filtering. These are essentially kind of great big metal meshes that are just trapping that really large debris and stopping it going on to the next step. Next one then, step 2. Bit of a large step. So the first step is we had sedimentation. So we basically just have a really large tank like this with all of the organic matter in the liquid float at the top. You basically leave that for a certain amount of time, and after a while all of the solid will essentially fall to the bottom and you will end up with your clearer liquid at the top. Okay, this solid is then taken out, and this is your sludge, and your effluent is now this top part of the liquid. Imagine like a pint glass with a load of sand and water, mixing it all up, letting the sand fall to the bottom, and then just carefully decanting the top part of the water off. So this is the effluent at the top here, and then you've got your sludge at the bottom. We then need to treat this. So the sludge is treated anaerobically. We need to learn all of these words, and then it's either sent to landfill, or often it's used to make biogas or fertilizer. The effluent, so the top part of the liquid, is taken out, and that's treated aerobically, and you bubble oxygen through it, and then you add microbes that essentially destroy the pathogens. You then go into another stage of sedimentation where all of those harmful microbes are then taken out and allowed to settle again. You make more sludge, treat it anaerobically, and then there's a final step where we do a final sterilization, again using chlorine most of the time, but you could use ozone or UV, and the water is then released into the rivers. Obviously, we get a lot of our drinking water from rivers, so what do we then do from the rivers? We then take it out of the river, we filter it, sterilize it, and then we can then consume it in our homes. Okay, so a couple of questions then, have a go at these. Why does wastewater take longer to treat than groundwater, for 3 marks? So pause the video if you want to have a quick think. So here's your answer then. Why does it take longer to treat? So it has wastewater has more steps, it has more organic matter, and it has more harmful microbes and pathogens, okay, i.e. takes longer to sort out. Okay, next question, 6 marker here. So what you might have to do is you may well have to say the differences between treating waste, fresh and seawater. So I'm going to divide this up quickly and have a go at answering this. So I would start with fresh because that's probably the easiest one to do. Could say ground instead as well. There's different words they could use for this. So your fresh water, I'm going to kind of bullet point this as quick as I can. What we're going to do, we're going to filter to remove solid, and then sterilize with chlorine to destroy bacteria. Okay, first bit done. Then I would say kind of seawater. So what's the issue with seawater? It's going to be salty, needs to desalinate. So use reverse osmosis to remove the salt. Issue, this requires lots of energy. Okay, lastly then, wastewater, I would say requires most steps. Why? It has more organic matter. So you first screen to remove solid, then aerobically treat effluent to remove bacteria. And then treat with Cl2 to discharge into rivers. I haven't put in about the anaerobic treatment for the sludge because that's mainly talking about actually what we do with the sludge rather than how we're going to treat that water, but that wouldn't be a bad thing to add into that. All right, lovely stuff. Okay, so if you do need any help, please do check out my other videos. Thanks very much for watching, and I'll see you next time.